A 32 billion parameter model from Qwen, known as QwQ-32B, is actually performing as well as a 671 billion parameters DeepSeek-R1. So this particular model QwQ-32 billion is actually trained with reinforcement learning. So this large language model, when evaluated across various benchmarks to assess mathematical reasoning, coding proficiency, and general problem solving capabilities, is performing very close to DeepSeek-R1, right? So over here, if you look at the benchmarks, on some benchmarks, it is quite close to DeepSeek-R1, and in some cases, it is better than DeepSeek-R1. So this is a very interesting result in terms of, a 32 billion parameter model performing on the equivalent of a 671 billion parameter mixture of experts. So if you look at it, during runtime, only 37 billion parameters are activated, right? But this is very interesting result. Hope that there is no data leakage or something, or hope that, this is not a model which works only very well on benchmarks. Okay. So how did they train this model? They used reinforcement learning. They followed a similar recipe to DeepSeek-R1. They started with the cold start checkpoint, and in the initial stage, they trained, they did reinforcement learning, scaled for reinforcement learning specifically for math and coding tasks. Instead of using traditional reward models for math, they used an accuracy verifier to ensure the correctness of the final solution. And for coding tasks, they used a code execution server to assess whether the generated code successfully passed the predefined test cases. So they were using this to generate the rewards for the reinforcement learning. So as training episodes progress, performance in both domains shows continuous improvement. So after this first stage, they added another stage for general reinforcement learning for general capabilities. So where they used general reward model and rule-based verifiers. So in this stage, what they are saying is that with small amount of steps, the model performance was increasing on instruction following, alignment with human preference and agent performance without performance drop in math and coding. So this is a very interesting model. This is available on Hugging Face Transformers. This is an open weights model. So they have released this on Hugging Face Transformers, right? It is also available on Qwen Chat. That is what they say over here. So you can actually try it on Qwen Chat. So I did a quick try on Qwen Chat, and I'm hoping that this QwQ-32 preview in the model selection is referring to this particular model. Okay. Because I didn't find any other QwQ-32 billion over here. And what I did was this is also a thinking model. It supports thinking. That's what they say over here. I said how many R's are in the word strawberry, my own spelling over here. So there is 2, 3, 4, right? So how many do you have? 1, 2, 3, 4. Okay. So there are 4 R's over here. Ultimately, it will say that there are 5 R's. Okay. Am I counting it wrongly? No, there is 1, 2, 3, 4. Okay. So ultimately it gives an answer that, there are 4 R's and there are 5 R's basically. Right. Position 3, position 4, and, in the end it's adding an additional R over here. I don't know from where. Okay. But yeah, you can try it for different things over here. Maybe I'll disable thinking and let me put this again and see what happens. So I have 1, 2, 3, 4 over here. Let's see. I don't know why this is still a really tough problem for, counting over here. See over here, I don't know why it is, taking this word and adding an extra R over here. Maybe it was present in the data set or something. So finally, how much it says it goes 5 R's, 5 R's. Okay, again. Somehow it doesn't solve this problem. So I'm not sure if it works as claimed, but this is an interesting model. You can go and try out and see. Okay. So I added a different version of strawberry over here, which has only 4 R's. Somehow it autocorrects it to 5 R's and then it does a mismatch over here. Yeah, so this is about QwQ-32 billion parameter model.